In this lesson, we use OpenSSL to generate RSA keys and understand what they contain. Here we show how to use OpenSSL to generate RSA private key and public key. The command is OpenSSL gen RSA, and we have option DS, which is using the 3DS to encrypt to protect the pass private key using a passphrase. And then we have option out, which specifies the file name we're going to save. The private key is private.pm, and the last parameter 2048 is indicate we are generating key size that is 2048 bit, and we are generating a 2048 bit private key. The private key is encrypted using 3DS with passphrase, okay, and saved in the private.pm in .pam file format. The private key file contains actually multiple information there. First is the D, the private key exponent. The next one is N, modulars, and then followed by P and Q with the other prime. P times Q is N. And then the other two numbers we are going to talk about when we are using the formula to OpenSSL command to display that. And we can use information in private key to extract out quickly the corresponding public key, which including the two tuple E and N. And actually these E and N are all part of the information encoded in the private key. No computation is needed. Remember that. Maybe it will show up in the test. The command is OpenSSL RSA minus the option IN private key.pm and option out phone using the format PM, and the option P public out, because we are going to generate pub key from as an output, and option out is specified we are going to save it as a public.pm, and input file is private.pm, and the key option is to be remembered carefully is pop out. Okay, here we use OpenSSL to show what is inside the public key. The OpenSSL command is OpenSSL RSA, and with option no out, because we are going to print out on the screen, and with option text, we are going to print out as ASCII, and incoming the format is PM format. Incoming file is public.pm, and so we are using the option IN. Okay, it shows the public key file contains two fields, two information there. The first one is the modular N. It consists of 248 bits, 8 bit per display here, and the public key exponent showing in the last line there. And actually it's 655737. And here let's show using the OpenSSL to show what is the inside the private key. The command is OpenSSL RSA with option minus text. We're going to print out on screen. Therefore we use option no out, and then we redirect the input file coming in, which is private. And we already unprotect the private key, so the file is saved as private_unencrypted.pm. We saw there are 8 different sections of the data displayed here for the private key file. They are modular N. The first one is modular N. The public key exponent E, which is 65537, the private exponent, followed by prime P and prime 2Q, and the 2 exponent and 1 coefficient. Since N and E are already there, there's no need for us to compute and generate public key from this file, as we showed it last time. And here is the page 60 of request for comment 3447, which is public key crypto standard PKS number 1, which describe in detail RSA cryptography specification version 2.1. It details the structure, in this page, it details the structure of public key and private key, what it consisted of. Here, exponent 1 is D mod P-1, while exponent 2 is D mod Q-1. The coefficient, the last one, is inverse of Q mod P.